Good morning, everyone. So today we will learn about the electrical property of silicon, germanium, gallium arsenide, and gallium nitride. So we are discussing this topic for the competition purpose and as well as some BTech courses. So first we'll discuss the property of this silicon, germanium, and gallium arsenide and gallium nitride. So first property of this band gap at the 300 Kelvin. Band gap means electron Eg is at 300 Kelvin. The silicon having the electron Eg is 1.12 electron volt, germanium 0.66 electron volts, and gallium arsenide 1.42 electron volts, and gallium nitride 3.4 electron volts. So the electrical, according to electrical behavior, this all four elementary materials having the band gap is like this. So types of the band gaps exist in all these. Silicon is indirect band gap, and germanium also indirect band gap, and this gallium arsenides and gallium nitride both are direct band gap. So because this is the third and fifth group compound, so you can do this is also called the compound semiconductor. This is called compound semiconductor. So this is behave as like the direct band gap semiconductor. So electron mobility of all these all four materials in case of the silicon electron mobility mu n is equal to 1350 centimeter square volt seconds, and in case of germanium electron mobility 3900 centimeter square volt seconds, and gallium arsenide 8500 centimeters per volt second, and gallium nitride 2000 centimeters per volt second. So this is the electron mobility of the germanium, silicon, and gallium arsenides. And hole mobility mu p is silicon is 480 centimeters per volt second, and germanium 1900 centimeters per volt second, and gallium arsenide 400 centimeters per volt second, and gallium nitride 200 centimeters per volt second. So another property is intrinsic semiconductor, intrinsic concentration. Intrinsic concentration is Ni. It decides the number of charge carrier exists in the any materials. So we can calculate the number of charge carrier existing in any material. So we can say that now intrinsic concentration in case of the silicon 1 multiplied by the 10 to power 10 per centimeter cube. In case of the germanium, 2.4 10 to power 13 per centimeter cube, and gallium arsenide 2 multiplied by 10 to power 6 per centimeter cube, and gallium arsenide minus 10 to power minus 10 per centimeter cube. So another thing, property number 6, the break electric fields. Okay, so this is 0.3 in case of silicon per megavolt per centimeter, and 0.1 megavolts per centimeter in germanium, 0.4 megavolt per centimeter in gallium arsenide, 3.3 megavolt per centimeter in gallium arsenide. So another last property is the resistivity. In case of the silicon, 2.3 10 to the power 5 ohm centimeter, and germanium 47 ohm centimeter, and gallium arsenide 10 to the power 8 ohm centimeter, and gallium nitride greater than 10 to the power 14 ohm centimeter. So this is the some few points. The band gap as like is the behave as like the this is germanium less than silicon, less than gallium arsenides, and less than this gallium nitride. Leakage current germanium less than silicon, less than gallium arsenide, gallium nitride. So this is the some few property. In case of the electron mobility mu, that is decide the speed of electrons. So highest electron mobility in gallium arsenide, germanium, and then gallium nitride and silicon. So power handling capacity of the and in this material gallium nitride is the highest power and handling capacity, gallium arsenide, silicon, and germanium. So why gallium arsenide are faster than silicon? Due to electron mobility of gallium arsenide is higher than the electron mobility of silicon. So we can say that na gallium arsenide are faster than silicon. So Comparison between this germanium and silicon. Silicon is more fancy when compared to the germanium, and this is due to reason silicon have smaller leakage current, high temperature application, high power handling capacity, power handling capacity. Four, abundant. It found abundant in nature. It means another most important property is silicon plus O2, that is easily can convert it into by using the oxidation process SiO2. This is called silicon dioxide, and this is work as an insulator. Okay, so maximum operating temperature for this germanium. So this maximum operating temperature of germanium is minus 60 degree centigrade to 75 degree centigrade, and for silicon minus 60 degree to 175 degree centigrade. It means silicon is handle much more temperature as compared to germanium. So another thing, the disadvantage of silicon is the this is conductivity is less as compared to the this now. So most important things is the gallium arsenide is the work as a negative difference, having gallium arsenide having a negative differential mobility. So some gallium arsenide applications, this is used for the fabrication of LED light emitting diode, pin diode is the high switching that work as a high switch, highly microwave switch, or this is tunnel diode, varictor diode used for the generation of FM signals. Okay, so gun diode impaired and the MMIC fabrication. So this is the some important points of the comparison between silicon and germanium.